we wanted to get with the real core trainings, and one of those was Lockout, Tagout, Tryout. A lot of you may be familiar with this. You've dealt with Lockout, Tagout over your career. Some of you, it may be brand new. This is one of those essential safety topics that keeps us alive, that keeps our fingers attached to our body and the rest of our body parts attached where they're supposed to be, because this is what keeps us from getting our fingers caught in machinery that turns on when we don't expect it. This is an essential safety topic. And I hope when you get done with the presentation today that you discuss this in your organization and say, how are we doing here? How well have we prepared our workplace for this? And are we trained? Do we have good procedures when it comes to doing our lockout, tagout? And so have that discussion. And like I always say, I'm happy to help out. If you need a boilerplate policy, if you have specific questions about a piece of equipment and how it would be best to lock it out, I'd love to have that discussion with you. So let's dive in. We've got a lot of stuff to talk about. Oh, that's a pretty rough video there. Shows somebody getting trapped by a machine. And that's really what we're talking about, is preventing unexpected energization, or turning on a machine when we don't expect it, when our fingers are in the machine or another body part is in there. That's something that could be life-threatening or could be a real painful thing. So today we want to increase your awareness of what the hazards are of this, help you understand the different roles in lockout, tagout, who does what, who can actually place a lock on and take a machine out of service. We want to talk about the steps to isolate a machine and some other ways to keep you safe as you're dealing with it. So what are we talking about in lockout, tagout? Well, this is an OSHA standard. It's called the Control of Hazardous Energy. And there is the citation there. And I always recommend that you go in and read the actual standard so you know what the requirements are. But it's for servicing and maintenance of machines, and it's to prevent unexpected energization of those machines or the release of stored energy. Sometimes we can have energy in a battery, a capacitor, or a spring, or gravity. There are a lot of different energy sources that can store energy, and it might release at a very inopportune time and cause us injury. And that's really our goal. Ultimate goal is to prevent injury to people. So already brought up just a few of these. They're energy sources. Electrical is the one that's pretty simple, right? We all know electricity is all around us, and it's hazardous. And if we've been shocked before, we have a great deal of respect for electricity because it doesn't feel very good. But there's mechanical energy, hydraulic, pneumatic, thermal, things like heat, steam, hot water, gravity, and even radiation are all energy sources that may need to be controlled through a process like lockout, tagout. So we ask ourselves, when do we use it? Well, it's when we're doing service or maintenance on that machine. I have to take the machine out of service and repair something, replace a part, whatever that may be, or if I take a guard off, or if I bypass a safety device, or I put any part of my body in the point of operation or danger zone of that piece of equipment. So in any of those situations, lockout, tagout, or something similar to it applies. I say something similar because there's an exception to this, and I'll just bring it up to start with. If I have a cord and plug piece of equipment, let's say a corded drill. We don't see many of those anymore. They're mostly cordless now. But I've got a drill and I need to repair something on it, or even just change a bit. I don't have to lock out, tag out a cord and plug tool because I'm in complete control. I do have to unplug it. If I'm going to do maintenance on that drill, I unplug it and I keep that cord in my control. That's an exception to this, but all other machines fall into lockout, tagout, the OSHA standard, and the requirements around that to protect us. All right, so let's talk about the people involved in lockout, tagout. We have two different groups of people. There are affected employees. What does it mean to be affected? Well, these are people who who are in the work area. They may be the operators of the machine, or they may work around this machine that has broken or needs to be maintained in some way. And so their job is affected. Their environment is affected by us turning the machine off. Okay. So basically they need to know what is lockout tagout. And if somebody puts a lock and a tag on this machine, I don't try to turn it back on. That's being an affected employee, respecting other people's safety by not turning the machine on, not trying to remove a lock or a tag. Okay, that's pretty simple. Affected employee. Then we have the other group of employees, and these are authorized employees. These are the mechanics, the people who are actually doing the service on the piece of the equipment, people who will be locking the machine out and performing the maintenance. Okay, obviously, authorized employees need to have a higher level of training than those who are simply affected by it. And so they also need to know what the hazards are of the machines, what the hazards are if these energy sources suddenly turn on, and they need to know the procedure and the methods used to control this energy. Okay. All right. And if I'm going to jump out. If people have questions, I'll jump out for just 1 second and take a look at, oh, it's not showing me there's chat. Okay, I'm not seeing anything in the chat there. I'm just going to go back and forth because I'm alone. Hey, I got it to stay at the, hopefully you guys isn't over your screen, but I can see it. Let's move on to the next part of this, which are really some terminology. Here's one. We have an energy isolating device. This is a mechanical device that physically prevents the transmission or release of energy. Okay, well, that's a big definition, but what it simply is, it's a switch, right? As we can see in this picture, I turn that disconnect off, and it disconnects the power. I put a lock on it, and that prevents somebody else from turning it on. So energy isolating device. It can be a disconnect like this. It can be a valve in a pneumatic or a hydraulic system. It could be something totally different than that. Sometimes we use chains. Excuse me, that's the device. That would be the lockout device. Sorry, I got a little ahead of myself there. But it could be a valve. It could be blocking that we put under something that is at height and has gravity as its energy source. Getting yourself into a machine is not a good thing. So we're going to lock out our machine. And so a lockout is a device that we use to put on that energy isolating device, and it just simply prevents us from turning it on. And this makes sure that the machine doesn't turn off unexpectedly. There's one key for this lockout device. Who has that? Well, the person that has that is the mechanic that is doing the maintenance. And every mechanic that does that maintenance needs to have their own lock and their key. So everybody is equally protected. And so you can see here that when I have more than one mechanic working on this piece of equipment or maintenance person, we put a hasp on this isolating device, and then I can put more locks. Well, what if I run out of space on that hasp? Well, I can put another hasp on that hasp and just keep adding locks. I've seen lockouts where there have been several hundred locks on that main lockout, and that gives every person working on the machine the same level of protection. Okay. The question is, and just one statement here, the first person to apply their lock is the last person to remove their lock. Okay. All right. Tag out. Each lock should be accompanied by a tag. This tag contains some critical information. One, who put this lock on this machine? We need to know who that is so we can determine what's going on with the machine. That's a person that we need to talk to be able to have a conversation, because sometimes A lock may be on a piece of equipment for an extended period of time. I've gone into places where there have been locks that had a quarter inch of dust on them. And I said, how long's that been there? And they looked and they said, oh, so and so locked that out. That's probably 5 years. Well, it's important to know who locked it out, so then we can determine what was up with the machine. Has it been repaired? And has that person, is the person outside of the machine now? Are they in a safe location if we need to turn that machine on? So tags are important as well. So who locked it out, and when did they lock it out? And you may have some contact information for that person as well. So OSHA gives us a little bit of leeway to just use tags instead of locks and tags. Now, I caution you on this. I highly discourage you from using a tag out system without a lock. Why? Well, it's super easy to cut a zip tie that you put a tag on. I don't want my safety hanging on a zip tie. I want to make sure that there's a lock there, and that's going to make somebody go to extraordinary means to remove that lock. And we need to train people not to do that, but I want to make sure that it's not easy for somebody to simply pull a tag off, turn the machine on, and put me in danger. Okay. All right. So authorized person's responsibilities. They need to notify the affected employees. Hey, we're going to take this machine out of service. It's going to be shut down. This is about how long we think it's going to take. And this machine's not going to work. Don't touch the machine. Don't try to turn it on. Those types of things, so they know what's going on. It's important to communicate when we lock a machine out. Okay. Supervisors have a key responsibility in lockout tagout as well. They need to make sure that we're doing it. They need to make sure that everybody that is working on machines, they're maintaining those machines, has adequate training to make them an authorized employee. Those authorized employees are only authorized because the employer gave them authorization to do that, and part of that is to have adequate training. So everybody needs to be trained. Let's talk about management. They need to look at our overall policy, make sure we've got a good written policy, make sure training is conducted, and then do periodic audits and see if we're doing it right. If we're messing up and we're not doing lockout, or maybe we missed an energy source, well, that's a problem. And so management has the responsibility to make sure that our program is working, is effective, and it's going to prevent people from having injuries. All right, we're covering a lot of stuff fast. Sorry, this is an hour subject that we're doing in a half hour, and so we're going to cruise through this one fairly quickly. But I do want to answer your questions, so type those in the chat box. Each piece of equipment should have a procedure on how to lock it out. What does that mean? Well, some pieces of equipment have multiple different energy sources. I've got electrical power, I've got pneumatic, I've got hydraulic, there's even a gravity component to that. All of those energy sources should be listed on the procedure along with the procedure to lock that out. Where's the energy isolating device, and how do I lock it out? That is a key step in making this work, because it's easy to miss an energy source if we're just in a hurry doing a job. So that's why the employer has the responsibility to build these procedures. So I pull up the procedure, I look at it, oh, there are actually 3 energy sources on this, and I have to lock all of those out, and I check them off each time before I do that. This is a key element to not having a problem. I'm here to tell you, I've seen situations, been involved with situations, one of them here at the Trust, where we had an energy source that was unexpected. And here at the Trust, it was a battery backup that our IT folks here had installed for our server room, and it backfed through the building. Now, fortunately, nobody was injured, but we learned some things about that, even here at the Trust, a simple building like this, where an additional energy source could have caused somebody injury. So we've got to look very closely. Some of those things to be able to build this procedure would involve the owner's manual, the documentation from each piece of equipment. May involve engineers who know the equipment and can be able to identify that, or somebody that is competent in being able to identify those energy sources and the proper manner to isolate those. Okay. All right. So let's burn through the lockout procedure. We have multiple steps. Number one is testing and diagnosing the machine. So the authorized employee is going to notify the operators, hey, we're going to lock this thing out, inspect the work area for safety, and make sure everything is there before we go ahead and do the lockout. Step two involves shutting the machine down. Now, this may be our normal machine shutdown, or it may be something specific for a lockout, and you want to look at your procedure for that. But we lock it down. We turn off all of the energy sources, and then we apply our lockout device. So turn that switch and apply the lock there. Close the valve and apply the lockout device there. If you look in this picture, there is a lockout device for a breaker. So that's a way that we can lock things out. And just here's the other side of that, where there are lots of devices that we can use to lock things out. This is a pneumatic valve. And it will not only lock out so no more compressed air will come in, but it will release the stored air that's on the downstream side of this valve as well. So I simply exercise that valve, and then I put my lock in place, and it's a good place. All right, I just see I have a question here. Does the trust have a template Excel file or similar for equipment-specific lockout plaques that can be shared with us? Yes, I will send out a boilerplate of that to everybody that signed up for the webinar today, along with I have a boilerplate policy and procedure as well. Or policy. So yes, we will do that. Okay. De-energization is step 3 of lockout tagout. What does that mean? That means we need to release stored energy that may be in the machine. Well, how do we do that? Well, you think of a spring. If I stretch a spring out, that's stored energy, and if I release that, that spring can shoot across the room or hurt me. And so other things would be a capacitor that's holding electrical power. I need to have a procedure to release that stored energy as well. Sometimes this is as simple as pushing the button to see if the machine starts up, or to release power that may be there. But it's going to be specific to the piece of equipment that we have. And we have to identify, is there potential for storing energy in this machine? All right, lockout procedure step number 4, verification of isolation. We got to make sure it works. Now, what does this mean? Well, in electrical circuits, we're going to test with a multimeter and test to verify that our lockout has worked. Now, we're going to use safe procedures to do that, so we don't put ourselves in contact with those electrical circuits. But we're going to use our tools to be able to verify that it's locked out. Sometimes, and in the title, the title is called Lockout Tagout Tryout. What does tryout mean? I'm going to push the button and see if this machine turns on. If it does, we got a problem with our lockout procedure. It didn't isolate the energy source. Well, is that a fail? Well, it's kind of a halfway fail. The lockout tagout failed, but the tryout worked, and that prevented injury. And so this is a key step in our lockout procedure, is to try it out and verify if it will start, and then put all of those switches in the safe or off position. All right, and I know we may have some questions on this, but we'll answer those as we get going. Lockout procedure step number 5, fix the machine, do the service, whatever it is that we're doing on that machine. After that, we are going to do what we call post-service testing. Now, we may or may not need to do testing where the machine is operating, but there are certain times where I put a new part in, and we need to test that machine to verify the tolerances are correct, or that things are working, and it needs to be done with power in place or the energy sources in place. When I do that, I need to verify that everybody is safe, all the tools are out of the equipment, and none of our body parts are in that point of operation, and only remove the locks necessary to test that part of the equipment. Inspect the area. A hammer inside of a machine, when you turn it on, is a bad problem, or a bolt or something like that. So we got to do good inspection before we do that, and then make sure that all the equipment components are intact. We test the operation. If everything's good, then we go to the last step, which is releasing from lockout tagout. So if everything's cleaned up, we notify the operators, whoever's over the machine, or the supervisor in the area. This machine is now safe to go back into operation, and we're done. Well, seems fairly simple, but I think you can see how important that procedure is. Some machines are really cut and dried. It's a simple electric motor. There's no capacitors on it, and we flip that switch, that disconnect, and we put a lock in place. We verify that there's no power to it, and we're good to go. But if I start having multiple different energy sources, or sometimes they're kind of tricky. You may have backup power. There's a generator or a backup battery somewhere in the system, a secondary source of energy. We've got to identify those. Okay, let's move on. Personnel changes. Sometimes this repair goes into extended shifts. So we go to, you may or may not have second or third shift, but sometimes we've been working on this a long time and I need to go home. I've put in a lot of hours on this, and somebody needs to take my place. Well, what do I do in that situation? Well, the reality is, in that situation, we're going to have both mechanics there, and as the one that's leaving removes their key, preferably that you have a hasp in place, and the one that's just got there puts their lock in place. And then the one that's leaving takes theirs off. But in some cases where it's just an isolating device, we're standing there side by side. I'm going home, so I remove my lock and they put their lock in place, and so everybody is protected throughout the process. Okay. Let's see. And lock removal. Can we ever cut somebody's lock off? Can we go out there with bolt cutters and say, we can't find this guy, let's cut the lock off? And the answer is yes, but no, yes and no. In most cases, we would never do that, because that's really what's protecting that person. We have one key for a reason to that lock, so that it's going to force us to go to these extraordinary means. Here's the important steps of this. This will involve management. It's going to involve some paperwork. If I'm going to cut somebody's lock off, I've got to go through a process. I'm going to inform management. I'm going to let them know we can't find this person, or this person has been gone for a long time, but their lock is still in place. And we need to remove this lock, and then some decisions will be made. But those decisions are only made after we go to the extent of finding the person. Maybe this person just went home, and now we need to get the machine running, and they live 30 miles away from work or more, and we call the person up, and they're like, "Oh, yeah, sorry, I left that locked out," or we just became aware that we need to have that machine running. And so we verify that that person is not in the machine. We physically look to verify that others are not in that machine as well, and go through the steps to ensure that if we take that lock off and start the machine, we're not going to injure somebody. What if I can't find the person? Well, if it's one of those things, well, the person used to work here 5 years ago and their lock's still on the machine, that's a lot easier to be able to verify. We need to go through some steps, and this should be documented how we do it. And once again, management should be involved in this process. Don't just go out willy-nilly with a set of bolt cutters and and start cutting locks off, because people's lives can be lost there. Lockout tagout is a key safety policy. It is a key procedure to keep our body parts in place and to keep us alive. I unfortunately have well, not unfortunately, I have an uncle. Unfortunately, my uncle had a nasty accident with one of these. He was working at a food processing plant, and he turned a machine off, crawled down in it, started wrenching on the machine, and a new employee walked out and said, "Why is that off?" Plunk, and turned the machine on, and he got his arm wrapped up in there in the machine and broke it in multiple places. Fortunately, it didn't kill him. But these are things that if we don't take the time, we don't make the effort to ensure that we lock the machines out, we could run into problems there. So encourage you to do this. If you've got questions, please type those in the chat box now. We wrap this up for the day. If you have questions specific about a machine, specific about procedures, please give me a call, and I'm happy to help out there. All right, I'm looking at our questions, and I don't see any more coming in. I am grateful, folks, that you took some time out of your day to come to this presentation, and hopefully that you attended a few others during our National Safety Month celebration, where we did monthly safety moments each week. And hopefully you learned some stuff there, and we would love to help you improve your safety program, and most of all, keep you safe and keep you going home so you can one day enjoy that retirement that we're all working for. Thanks, folks. Appreciate all you do. Go out and have a safe day.